This is a reassessment for kinematics, and as you can see at the top, I have what they're drawing. A skier is going down a slope, a frictionless slope, that's 50 meters long at a 32-degree angle. And at the bottom of the slope, the path levels out and becomes horizontal, so it becomes less icy and the skier begins to slow down. And the horizontal path is 140 meters long. And what it wants to know is what is the speed of the skier from the bottom of the slope, and what is the coefficient of kinetic friction between the skier and the horizontal surface. So you have delta y and you have a of y. You know that the initial velocity is 0, and you got to solve for time, or the v(f) of y, and use the equation shown right there. Delta y equals viy times time plus 1/2 at squared. You know delta y is negative 26.496, and you know that the initial velocity is 0 because he's at rest before he starts going down, and you know that the acceleration of him is negative 9.81 due to gravity. So you got to find time. You get everything to one side except for time, and then you end up getting t equals 2.324 seconds. And you figure that out using law of sine and cosine of the angles given to you to find the drop and the horizontal of the right triangle right there. And you take what you have and you plug it into the formula again, and you end up getting the final velocity is 22.082 meters per second. And then for the second part of it, I drew a little free body diagram. You got friction going towards the back, your normal force going up, and gravity going down. And you know F of n is equal to mg, and F of n, the friction is of mu k times F of n. And you know what F of n is 6.18.03. And using the conservation of energy equation, you have delta x, you have your meters, and you have the final velocity, which is 0, minus the initial velocity, which is 22.082 squared. And you just do the math, divide it out, and you end up getting coefficient of friction, mu of k, is equal to 0.19.